In this short video, we're going to look at some properties of conditional probability. The probability of E given F. Once again, that means you're looking for the probability of the event E, but you're given some additional information that the event F occurred. So, let's look at this formula. The probability of E given F plus the probability of the complement of E given F. Remember, every time you run the experiment, either E occurs or it does not occur. 100% of the time, it will always be either E occurs or it doesn't. So if we know that the event F occurred, we know in both cases, we know that this is going to equal 1. Because the probability of E plus the probability of E complement is 1. So if you're told that F occurred, well, the probability that E occurred, if given F occurred, plus the probability that E did not occur, given F occurred, must be 1. And let's maybe do an example here. Usually in a Venn diagram like this, I'll put, just as a little cheat sheet, 16 is the number of elements in E. The number of elements in F would be 11. All right, let's see if it works. What is the probability of E given F? So if F occurred, that means we're in this circle. We know that F occurred. So what is the probability that E occurred if we're living inside this circle? Well, here's the number of elements in where E occurred, and there's 4 where it did not occur. So 7 out of 11 is the probability that probability of E given F. That's 7 over 11. All right, the probability that E did not occur given F. Well, given F means we're still in this circle. And how many, let's see, we've got 11 in that circle. These 7 are in the E circle. These 4 are in the E complement portion. So 4 out of 11 times is the probability that E did not occur given F. And that's equal to 11 over 11, which is 1. All right, let's look at the second one. The formula for this, the probability of A union B given F. Well, before I write that down, I'm going to recall that the probability of, and I'm going to use letters other than A and B, let's say C union D, is equal to the probability of C plus the probability of D minus the probability of C intersection D. Okay, because you don't want to count any probabilities twice. So this probability counting formula we know from an earlier section. Well, it turns out that the probability of A union B given F is going to look a lot like this, only using A and B, but you just have to put given F in each one of these probabilities. So that's going to be the probability of A given F plus the probability of B given F minus the probability of A intersection B given F. That's the formula. And let's see if we can come up with an example here. We'll call this circle F, and then the left circle A, and the right circle B. And maybe I'll write some numbers in here, like 2, 3, 7, 11, 5, 4, 1. I just randomly put some numbers out there, and whatever, you can put a number out here, it won't affect it. So what I like to do is do my little cheat sheet here. That's the set F. How many are in F? 2 and 3 is 5, 16, 23. Right, so in the F circle is 23. I probably don't need the B and the A circle, so I won't worry about those. We'll see if I need them. All right, so the probability of A union B given F occurred. Let's figure out what this probability is. F occurred means we're in that circle right there. Which of those regions, see these 4 regions that have numbers in them, which of those 3 regions are in A union B? The bottom 3. A union B is this whole figure 8 right here. Right? So, given that F occurred, we've got 2, 7, and 11 that are in A union B. So that would be 2 and 7 is 9 plus 11 is 20. 20 over, how many are in F? The circle, 23. So we know that's 20 over 23. Let's make sure this formula works. What's the probability of A given F? So given F means you're in this circle. Which of those numbers are in A? The circle A is right here. So the 2 and the 7 would be in the circle A. So that's 9 over 23. That's the probability of A given that F occurred. There are 23 items or elements in F. 9 of them, that 7 and the 2, happen also to be in the circle A. All right, plus the probability of B given F. So here's the circle F. If it occurred, that means you're in the F region. What is the probability of B? How many elements are in the circle F are also in the circle B? Well, this 7 and the 11, right? So that would be 18 over 23. Minus, all right, what's the probability that you're in the football region of A and B, given that you're in F? Given that you're in F, which of those regions, is in A intersect B? A intersect B is this right here, so just the 7. 7 over 23. Let's see what we get. Have the same denominator, so 9 and 18 is 27. 27 minus 7 gives us 20 over 23. So, of course, that formula works. 20 over 23 is equal to 20 over 23. All right, for the last one in this video, notice how similar it is to the previous problem. The Venn diagram is different, which we'll see in a minute. It needs to be. If A and B are mutually exclusive, what does that mean? It means that A intersect B is equal to the empty set. It means they do not overlap at all. So I'm going to call, which 2 of these 3 circles don't overlap? The left and the right. So I'm going to call that circle A, this one B, and then this one is going to be F. There's really no other way to do it. Well, I guess I could have called this one A. I could have swapped the A and B, but F has to be the one in the center because A and B don't overlap at all. Well, do you remember when that's the case, what do we have? Remember this? The probability of C union D is the probability of C plus the probability of D minus the probability of their intersection. Well, the probability of their intersection will be 0 in this case because they're mutually exclusive. So I could say if they're mutually exclusive, I'll use C and D again. C union D, the probability is the probability of C plus the probability of D. I don't have to subtract the probability of their intersection because the probability of their intersection is 0. They don't overlap at all. They share no common elements, the 2 events. All right, so all we need to do is basically get rid of this term here, which is a 0. So it's going to look very much like above. The probability of A given F plus the probability of B given F. That's the formula. So let's throw some numbers around here. Maybe I will put similar numbers as before. 3, 2, 5, 9, 11. And we can put 10 out here. It doesn't matter. We're not going to use that number. So remember what this means. This 2 is the football shape. This 5 is in between. This is this middle region. The 9 is this football shape. The 11 is this kind of Pac-Man, half-moonish kind of thing. And this 3 is this half-moon kind of thing over here. So notice that A has 5 elements in it, 3 and 2. F has 2, 5, and 9, 16. B has 20. Let's just show that this is true. Let's show that for this particular example I'm doing, what's the probability of A union B given F? Given F means that occurred. So that's basically our sample space for this problem. What's the probability of A union B? How many elements are there in A union B, or A or B? Well, not the 5, but the 2. The 2 is in A, the 9 is in B. So A or B means you take 2 plus 9, 11. 11 over, how many are in the F circle? 16. So 11 over 16 equals, what's this? Probability of A given F. If F occurred, given F, what's the probability of A? Well, out of the 2, 5, and 9, which of those numbers are in the circle A? The 2. The 2 is in the circle A, and the other ones are not. So that would be 2 over 16 plus probability of B given F. So F occurred. Of the 2, 5, and 9, which of those numbers are in the circle B? Well, just the 9. So that's going to be the probability of B given F is the number of elements in there, 9, over the number of elements in F, which is 16. 9 over 16. Does that work? 11 over 16 is 2 over 16 plus 9 over 16. So, yes, it does work.